Miss A. Alright, this is your red pen check for the Pythagorean theorem and rational and irrational number video. So in the description box in this video you'll see all the times for all the specific questions, so you don't have to run through the entire video. All you need to do is look at the times and the circled questions on your paper that you need to focus on instead of watching the entire video. Unless you want to. I mean, you're more than welcome to, but, you know, you don't need to. At the very end of this video, a lot of you requested to see my dogs. Hank and I will make an appearance at the end. Alright, so without any further ado, let's get started. Okay, so we have question 1. Alright, question 1 here says, is this a right triangle, and show your work. And what you should have circled was no. And to show your work, you needed to plug in 5, 12, and 16 into the Pythagorean theorem and show all of your steps. So I know that 16 is C because it's the largest number that's provided. So I'm going to have 5 squared plus 12 squared equals 16 squared. And all in all, that's going to give you 169 equals 256. Okay, those two things are not equal, so therefore these side lengths do not provide a right angle. Alright, moving on to 2. Alright, so find the distance between the points -5, -4, and 4 and 8. So 2 was instructed for you to use the coordinate plane. Now if you didn't use that and you used the slope distance formula, that's fine, as long as for 3 you used the coordinate plane then. So let's get to it. So -5, 4. I'm going to start at the origin. I'm going to go over -5 and then down 4. This is going to be my first coordinate point. My second one is 4, 8. So I'm going to start at the origin, move over 4, up 8. Okay, there we go. This is my line. Okay, and to show and to apply the Pythagorean theorem here, I'm going to find my slope, or draw a slope triangle between these 2 points. So I'm going to go over 1, 2, 3, 4, 5, 6, 7, 8, 9. So the distance of this side is 9. And then I'm going to go up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so as we can see now that we have a triangle happening here. That's why we call it the slope triangle. So I have my A and my B, and the distance between my 2 points is going to be my hypotenuse, or the C. And I'm going to stress here that I've seen a lot of mistakes when it comes to this, that students either just gave me the slope and didn't apply the Pythagorean theorem. So just to be really, really clear here, that when we use a slope triangle, we are finding the side lengths of our triangle, and the distance between the 2 coordinate points is the hypotenuse. So I'm going to plug 9 and 12 into the Pythagorean theorem and then solve for my C. So I end up with 9 squared plus 12 squared equals C squared. And all in all, this ends up being 225 equals C squared. Okay. Now remember that when anything is squared, this is literally C times C equals 225. And what that means is that one number multiplied by itself gives you 225. That's why we want to take the square root, because we're undoing the squared. There. So we end up with C equals, now 225 is a perfect square, so we end up with a whole number, or a rational number. So the distance between -5, -4, and 4, 8 is 15. Okay? Alright, let's move on to 3. Now 3, you're not supposed to use the coordinate plane, so I'm not going to use it. So let's looking at this. The slope distance formula that I'm going to use is going to be x1, y1, and x2, y2. So what this is telling me is I'm finding the distance between this y point and this y point, and this x point and this x point. That's going to give me my legs of my right triangle, or my slope triangle without the visual. So I'm going to have 2 minus 10 over negative 6 minus negative 8. And that's going to give me negative 8 over 2. Okay. You could have also done it the other way, where you had 10 minus 2 over negative 8 minus a negative 6. And that would have given you 8 over negative 2, which is perfectly fine. Same thing. Or so this is my A and my B, and remember, distance between 2 points is always going to be C. So I'm going to plug those two values into my Pythagorean theorem and solve for my C. So I have negative 8 squared plus 2 squared equals C squared. Now, squaring again is that same number multiplied by itself twice. So I'm going to actually break this apart and show you what it looks like. So whenever we square something, it looks like this. Okay, I'm really breaking it apart. So negative 8 times a negative 8 is going to give you a positive 64. So two negatives multiplied together gives you a positive. So you get 64 plus 4 equals, now we don't know what C is yet, so I'm just going to leave it as C times C. I'm going to bring this information over here because I'm running out of room. And then you end up with 68 equals C times C. And just so you can see the similarities here, that there's a connection between these two things. So whenever I see C times C, I can rewrite it as C squared. And when we now I need to take the square root, and when I take the square root, I'm finding this C. And that's going to give me approximately 8.2 is approximately C. Now you could have also left your answer as an exact, as 68 equals C. Okay. All right. And moving on here. All right, number 4. So find x from the drawing below. So we're still using the Pythagorean theorem, a squared plus b squared equals c squared. Okay, this is probably the one that I saw the most issues with, mainly because of two things. This square root of 26 really threw a lot of students off, and also identifying our c was hard. So whenever we're looking for what numbers to plug into our Pythagorean theorem, we need to find c, because that's the only one that truly matters. So I know that c is always directly diagonal from the right angle. So that means that 14 is going to be my c. So I'm going to plug that in just as it looks. And I'm going to do the same thing for 26. 26 is going to be my a or b, it doesn't matter. So I'm going to plug that in as it looks, just how it looks. I'm not going to just take 26 and I'm not just going to estimate the square root of 26. I'm going to put it in as it is. So you get the square root of 26 squared plus b squared. And just to keep things consistent, I'll make that x squared because we are trying to find x. Whenever you square a square root, you end up with the number underneath the square root sign. The reason for that, if you were to use PEMDAS, you would do what's inside the parentheses first. So you would take the square root of 26, and then you square that, and you end up back where you started. So you end up with 26. So 26 plus 8x squared equals, that ends up being 196. Okay? And it's just solving for a variable from here on out. So you just subtract, x squared equals 170. Take the square root of that. You get x equals 170, or x approximately is 13.05. Okay. Now, if you had done what I saw a lot of students do, where they squared 26, you would have ended up with a much larger number on this side of our Pythagorean theorem. Now remember that this literally says a squared plus b squared equals c squared. So that means that c has to be the largest number. So if a squared becomes larger than c squared, then something happened. So that doesn't make any sense. So logically, when we're looking at that, we can see that, let's say that I did the error that a lot of students ended up doing. So you have 26 as my A squared plus x squared equals 14 squared. Let's say that you did this. Now, this is, I'm looking at what you're looking at, and it makes sense as to why you would try to do this. But remember that the Pythagorean theorem says that a squared plus b squared equals c squared. So the sum of these two has to be equal to this. So that means that a and b has to be less than c. 26 times 26, or 26 squared, gives you 676 plus x squared equals 196. And if you take 196 and subtract 676, you get x equals negative 480. Now, the reason why that doesn't make any sense is because you can't have a side length that's less than 0. So think about that for a moment. We're looking at lengths here. Lengths. Now, whenever we're thinking of a length, it has to be greater than 0. Otherwise, it doesn't exist. So if you have a length that is a negative, then that in itself doesn't make any sense. So that's just an error check. So don't beat yourself up if you did this, because it's a common error and it's easily fixed. So instead of taking this number and plugging it into your equation, just remember to take the entire thing. So make sure that you take this whole thing and plug it in for A or B, and then use the PEMDAS method of taking the square root of 26 and then squaring that. And that kind of makes sense as to why we end up with 26 again. So if you're not completely sold on that, grab your scientific calculator really fast and type in the square root of 26, hit enter, and then find that button that looks like this, hit 2, and you will get 26 again. So just to, just to check me, like if you're like, I don't understand that, Miss A, that doesn't make any sense to me. So grab that calculator and do that on your own. So yeah, grab your calculators. If you don't have a scientific calculator, you can always go onto the internet and just type in scientific calculator, and I believe Desmos will have a free available one for you that you can try it out. All right. Let's move on to the 5th question. All right, so don't hate me because I can't pronounce these cities. So I'm just going to call this city A, city B, and city C, or distance A, B, and C, just to help me out. So I know the distance between this city and this city. And what this question is asking you is to take the information that's been given to find the distance between here and here. So I'm going to first make a line connecting those two cities and put a question mark because I don't know that distance. Here to here, question mark. I don't know that distance. So I'm going to use all this information given and see if any of it is going to help me find the distance between here and here. And I know that I'm going to use the Pythagorean theorem to help me with this somehow in some way. So I'm going to rewrite the Pythagorean theorem just to keep it fresh in my mind. So from here to here, I have 142 miles. So from here to here, 142 miles. And then from here to here, that's 117 miles. Okay. And my last one, here to here, is 280 miles. Alright, so looking at this, I'm automatically noticing that this provided information is moot. I don't need it. It's not going to help me at all because it's not even connected to the triangle that I made. So looking at this right now is I can tell that this is going to be my C value. So that means that this is going to be 142 squared. And I know that it's my C because it's the largest provided number. And also, if I was to draw a little right angle square right here, it's directly diagonal from that right angle. So I'm going to plug in my 117 squared plus my question mark, or my b squared. And all in all, this gives me 117 squared gives me 13,689. So 13,689 plus b squared equals 20,164. Here, subtract 13,689 from 20,164. Don't mind all the clicky clack clack. My husband is playing a video game right now. Alright, and then that gives me 6,475. I'm going to take the square root of that, both sides, and you get b equals a square root of 6,475, or you can write b as approximately 80.46. So that means the distance between this city and this city is about 80.46 miles. Okay? Alright, and here we go. Alright, so let's look at this first. So we have a complex figure, and we don't know the y, and we don't know x. So we don't know this side length, and we don't know this side length. Okay, looking at both of these triangles, I'm going to use the one that provides two side lengths, because you need two in order to find the third one. And I'm going to use my little trick, finding that right angle and drawing an arrow, and that is going to tell me the hypotenuse, or the longest side. I'm going to do the same thing here. Okay, so that means when I find my y, that's going to be my c value for my second triangle. So I'm going to plug 6 and 7 into my Pythagorean theorem so I can find y first. So I get 6 squared plus b squared, let's just keep that as y squared, equals 7 squared. This is going to give me 36 plus y squared equals 49. Subtract on both sides, you get y squared equals 13. Square root, y equals the square root of 13. Or you could have y is approximately 3.6. Now, when you go in, so what you put here is square root of 13 or 3.6. Either answer is fine. But when you go back and you try to solve for x, you want to use this answer, because if you use an approximate, you're going to get an approximate answer. We want exacts, though. And this is also really good practice for what we did in question 4, where we took the square root of 26. It's the same process here, because we're going to have to use that square root of 13. So now I'm going to solve for my x. So I have 2 squared plus my x squared equals the square root of 13 squared. See how we're kind of going back to what we did in question 4. So I get 4 plus x squared equals 13. Remember, you take the square root of 13 and then you square it, you're going to get back to 13. Subtract 4 on both sides and you get x squared equals 9. Take the square root, you get x equals 3. There we go. I had a lot of students, what they ended up doing is that they stopped right here. They said x equals 9. Now, it's incorrect, because you didn't find just x. You didn't find me that x equals 9. You said that 9 times 9 equals 9. So just looking at that right here, now we know that that's going to be 81 and that's going to be 9. So there's an error here. So remember that whenever you get to this point, you have found x times x equals 9, but you need to take the square root of x and the square root of that number. So over here you should have 3. Alright, and for 7 and 8. Alright, and for 7, how this kind of worked out was that if you took the was to go, okay, the perfect square right next to 18 would be 16, and the next one would be 25. 18 is closer to 16, which means that the square root of 16 is 4, so the square root of 18 is going to be closer to 4. Okay. 64. Okay, square root of 64 is 8. So we'll go here, because that is 8 times 8, or that is 8 squared. Okay. So we get the square root of 64 here. Square root of 5, okay, the perfect square just below that is 4, and the perfect square just above that is 9, and 5 is closer to 4, so the square root of 5 is going to be closer to 2. Okay, and we'll come back to this one. 6 over the square root of 9. So I told my students just take it one thing at a time. So how can we reduce this? How can we make it more simple? Okay, the square root of 9 ends up being 3 under 6, and that reduces down to 2. So 6 over the square root of 9 is 2. Alright, let's look back at this 3 times the square root of 9, or sorry, 3 times the square root of 3. 3 times the square root of 3. Okay, what perfect square results in the root of 3? 9. So we would have to take the square root of 9 in order to get 3. And then we just keep this where it is. So we get the square root of 9 times the square root of 3. And we can mesh those together. So we end up with the square root of 27. Okay, and the square root of 27 is in between the square root of 25 and the square root of 36. So, and 27 is closer to 5, or 25, so the square root of 27 is going to be closer to 5. Okay, and we're done with that one. Alright, circle the numbers below that are rational. Remember, a rational number can be written as a simple fraction. It can terminate, it can repeat, and it can be a perfect square. Okay, so looking at these, I know that the square root of 12 is not a perfect square. So that must mean that this fraction is a complex fraction. So I'm going to say, nope, that's not rational. Square root of 16 is 4, and that's a whole number, and it in decimal form that terminates. So this one. And this is a repeating decimal, so that's a rational number. This one is not rational because it has pi. Pi is a famous irrational number, so that one can't be rational. And this one is rational because it does terminate, even though there is no pattern. So remember, it can terminate, it can have pattern, it can be written as a simple fraction, and it can be a perfect square. So it can be a lot of different things. Okay, so these are your answers for 8. Alright, so there we go. If you have any questions, please make sure to ask your teacher. I know for my students that the retakes are going to be sometime this week. So yeah, good luck everybody. See if I can get my dogs to say hi one more time. Hey, come here. Come here, Hank. Come here. Hello. Hello. Yes, say hi to the camera. Say hello to the camera. Yes, okay. Okay, up. Nay, come here. You haven't said hi very much. Nay, come here. Nay, come here. Hank, back. Up, Nay. Oh, yeah. Up. Yes, good job. Okay. Yes, hello. Bye-bye. Alright, there you go. Now you gotta meet my dogs. Alright, I'll see you guys later. Bye.